So again, thanks so much everybody for joining me today. I'm super excited to talk to you about Solana, the world's first web scale blockchain. In other words, the world's first super fast, super high throughput blockchain, which I personally believe is going to be a technology that really helps a lot of the promised benefits of blockchain become a reality. So let's dive right into it. First of all, who am I and why am I talking about this topic? So again, as Mackenzie said, my name is Grace and I work as an interaction designer at a global design firm called IDEO, specifically out of our Tokyo office. Before that, I was also a software engineer, mostly working on the front end and UX side at startups in New York and in California. First at Coursera, which is an online education company, and then at Button, which does mobile commerce. Shout out to Jiachi, who I met at Button and who actually got me into speaking for Women Who Code. Even before that, I did a BS and MS in computer science with a concentration in human-computer interaction at Stanford, which is how I got into sort of this intersection of design and technology. And as you can tell from these slides here, I'm also a bit of a hobbyist illustrator, so we'll have some whimsical illustrations to go along with the slides today. A little bit also on part of how I learned about blockchain. Although I'm not personally part of Collab, IDEO has a division called Collab, which invests in ventures in crypto and blockchain. Since 2015, Collab has been working together with startup founders in this space to build out really meaningful applications which are at the intersection of human-centered design and blockchain. And since 2018, they've also been investing in early-stage crypto founders with the Collab Ventures Fund. And recently also launched a residency, which helps incubate and accelerate early stage teams. So feel free to look up Collab if that's something that's interesting to you. All right, so now on to the meat of today's talk. So we're going to first start out with a little bit of background on decentralized finance. I'll get into also the term itself and what that means, DeFi. Then after we've talked a little bit about the scaling problem in blockchain in general, I'll talk about how Solana solved this scalability problem from a more of a technical perspective. And then finally, we're going to dive in a little bit into the Solana ecosystem as it stands today, learn about what exists, how you can get started building, and also where some of the exciting potential applications that Solana Scale enables. So let's jump right into it with DeFi's race for scale. Start with a little bit of history. So as some of you may know, the first ever cryptocurrency is called Bitcoin, and it was published anonymously in a white paper by this guy who goes by the name Satoshi Nakamoto, which is a system that he described as a system for peer-to-peer electronic cash. This currency, which exists purely digitally and doesn't require this sort of trusted intermediary. So while Bitcoin was really revolutionary and remains obviously something that people think has a lot of value, it does not actually support these sort of custom programs, which you can see on Ethereum and also, for example, on Solana. And it's also, pretty slow and fairly expensive to transact on even now. It takes about 10 minutes to confirm transactions. This is a term called block time, which we'll revisit, and a couple dollars to make a particular transaction. So while it's something that was definitely revolutionary and remains relevant, it's not scalable in the way that allows for these really open application development. Then fast forward to 2015, we have Vitalik Buterin releasing the white paper for Ethereum, which completely changed the crypto world as a blockchain with a built-in Turing-complete programming language for writing what's called smart contracts. So essentially these self-executing applications built on top of the blockchain that push the world of crypto even further by allowing anybody to come in and really kind of not take advantage of this property of blockchain, of not having this sort of centralized identity to be able to build any financial application that they can imagine. It also advanced on top of Bitcoin in both the block times and transaction fees. It takes 8 seconds roughly to confirm a block on Ethereum compared to that 10 minutes on Bitcoin. And the transaction fees, at least originally, were also much lower, although I'll get into this too. They've recently spiked quite a bit. So they're also hovering around $3 average right now. So this ability to write smart contracts, introduced and popularized by Ethereum, led to the rise of a movement called decentralized finance, or more commonly known in the community as DeFi, which is essentially just these financial applications that use blockchains as the central way to get everybody to basically agree on what's happening to the money, instead of what's more traditional, like a central authority, like a bank or a brokerage, say like JP Morgan or something like that. And DeFi has really taken off in the last year. You can see this is a chart of what's called total value locked, or TVL, which is a pretty common metric used in the space, just to measure basically the amount of money that people have put into these DeFi applications. And one example is something where you can sort of put in money in order to earn some amount of interest. And so that's considered the money being locked in one of these applications. And so the total amount of money locked in DeFi now is approaching $15 billion, which, if you can see, it started out in the low billions just back in January, is like pretty insane. So while that's definitely like a positive in terms of interest in this space and people coming together to build on it, the flip side is a corresponding spike in the time and cost of transactions. It's not free, unfortunately, and also not instant to confirm all of these transactions, to validate them, and to pay out the rewards for the people doing so. And you might have heard of miners, for example, on Bitcoin. That's what they're doing and earning money for. And so the more people interested in building on Ethereum, the more expensive it becomes. And this is something that I actually experienced personally when I was building out Wallaroo, which is a little high interest savings app that my co-founder Yutara and I prototyped over the summer as part of Mozilla's MVP lab. And although we just discovered that it was made possible to provide pretty amazing returns via these other DeFi applications that we could compose in the Ethereum space, it still doesn't make sense to pay like $20, which is how much it costs for us to make some deposits and withdrawals due to the complexity of the code we were executing on Ethereum, just to deposit small amounts of money. So the fees were really the blocker that we personally experienced and caused us to look for solutions. So speaking of those solutions, there are a lot of players in this game right now who are trying to compete to win this race for scale, which includes both layer 1 blockchains. So basically an entirely different from the ground up infrastructure for a blockchain, which includes like Solana, Cosmos, Polkadot, and also what are called layer 2 solutions, which are basically built on top of Ethereum. And they, for example, might process some amount of transaction off-chain, so not directly on the blockchain, do what's called, in many cases, like a roll-up, so basically sort of packaging them up and then putting them back onto the chain. Whereas people who, or I suppose you can say supporters of layer 1 solutions, often tout that they have shorter like deposit and withdrawal times and shorter confirmation times and are more composable. On the other hand, layer 2 solutions will often point to the fact that, well, everyone's kind of already on Ethereum and the projects are on Ethereum, so there's pretty significant switching cost to bring people over onto a different blockchain, which could also fragment the ecosystem. So a lot of folks who see positives on both sides, and no clear winner yet. This problem of scale was described by Vitalik, the founder of Ethereum, as the scalability trilemma. So basically, when it comes to architecting a blockchain, claimed at least all blockchains until that point always had to make some trade-off, and that's between these 3 points of this triangle: scalability, security, and decentralization. So both Bitcoin and Ethereum, for example, have optimized for security and decentralization, in that it's pretty hard for a malicious actor to get away with, for example, saying, yeah, Grace just sent me $200 of Bitcoin, and for someone to not really be able to catch that is kind of what's meant by security in this case. And they've also optimized for decentralization. So again, no one person or it's pretty difficult for anyone to actually take control of much of the network because it's decentralized over a lot of different actors or nodes. But in exchange for that, they've traded off scalability. So both Bitcoin and Ethereum actually only support around the order of 10 transactions per second, which if you consider the fact that a modern financial network like Visa can handle 65,000 transactions per second, makes it pretty clear that they're still pretty far from being able to handle this level of real-world volume. But Solana, which is, again, of course, the topic of this talk, actually does solve the scalability trilemma. And in the next section, I'm going to get into why. But Solana was designed in 2017 and put forth in a white paper by Anatoly Yakovenko, and it's the first secure decentralized blockchain that actually offers performance in line with that of a single node. So that's actually kind of the inspiration for Solana originally. Anatoly and some of his other previous coworkers from Qualcomm had been noodling on these ideas for a long time of particularly how you can make a network of nodes have the performance and behavior of like just a single node on the network. And the fact they've actually achieved that now in blockchain is pretty groundbreaking. So again, let's get to the meat of the talk, which is how on earth is that possible? So before we get to the technical details of how Solana is so fast, let's first talk about why most decentralized blockchains are so slow. And we're going to have these little characters help us out for the rest of this talk to explain some of these concepts. Over on the left, we have Reggie the Red Panda, who walks into a convenience store and he's like, "Can I pay in Bitcoin?" And then on the right, we have Wally the Wallaroo, who's like, "I don't know. Can you stick around for 15 minutes so I can see if your transaction actually went through or not?" And this is kind of just a silly crypto community joke that shows how these older blockchains, while groundbreaking in many ways, are not quite ready for real world scale. So zooming back out again to how blockchains work. In a blockchain, when transactions are sent to the network, these folks called block producers will include them in these groups called blocks in exchange for a monetary reward. And so that particular blockchain's protocol will specify the amount of time that should pass between each block so that the network moves forward at this fair and consistent rate. But since this is a decentralized network and the nodes can't trust each other, all of the other nodes on the network can serve as validators. And what a validator does is take a proposed block. Let's, for example, Wally here is like, "Hey, I have this block of transactions. Let's add it to the chain so I can get my reward." And then, if, for example, if this were Ethereum 2, there might be a group of like 128 validators who then get to vote on whether that block is valid or not and should be added to the chain. And so there are two factors that go into whether that block is legit. And one is whether the transactions themselves are legit. So there's no like fraudulent transaction that says that, for example, everybody should, or like this random person B should send me like $10,000 of Bitcoin. And also whether enough time has passed between those blocks, basically obeying that protocol delay that I mentioned in the previous slide. So what this mechanism poses is two major bottlenecks when it comes to the speed and throughput of a blockchain. One is processing transactions, so we can decide whether those transactions are legit. And second is the peer-to-peer communication, the overhead of these validators having to actually communicate and gather these yes or no votes before a decision can be made on whether that block should be added to the chain and the network can move forward. And so Solana's key innovation is called proof of history. And it's a historical record that serves as a global clock for the entire Solana network, which alleviates this second bottleneck, which I mentioned, which is the communication overhead of coming to consensus. So what exactly is that proof of history thing that I mentioned, and how does it serve as a clock? So here is where we're going to start getting pretty technical. This is not something that's easy to understand in 5 or 10 minutes. So just bear with me. We'll get through it at like I think a relatively high level. And if you're curious, I actually encourage you to go ahead and read the Solana white paper after. It's just publicly available and gets really into the nitty gritty. So that's actually pretty fun if you're interested in the technical details. But again, going to our high level, what proof of history is essentially the sequential runs of this, what's called a verifiable delay function, or VDF, which is a function that takes a certain number of steps to evaluate, and therefore a certain amount of time to evaluate, but can also be efficiently and publicly verified. So it takes a certain amount of time to generate some output, but that output is really quick for anyone else to say, yes, that's a legit output. And so how Solana actually uses this VDF in proof of history is as a simple SHA-256 hash function, which is run recursively. So it starts with some arbitrary starting input. There's an unpredictable output, which is then used as the next input, which is used as the next input, and so forth and so forth. And because of these two properties, one were of SHA-256, you cannot predict the output of the function from the input until the function is completely executed. And it's also pre-image resistant, which means that given a particular output, you can't predict what input would actually lead to that. It means that this recursive series of hashes has to be generated in sequence by essentially a single core, so it can't be parallelized. And that in turn ensures that real time actually passes between each hash. So at periodic intervals, not every single hash, since this is running really, really fast and we don't actually need all of them for the purposes of timing our clock, we're going to record that count and output hash into the public ledger, which if you're not familiar with the term, you can just kind of think of this database that's recording what's happening in the blockchain. And so because SHA-256 in particular, mainly due to actually a lot of research driven by the interest in crypto and Bitcoin, has actually been super optimized. It's actually really difficult for even a supercomputer that's specifically designed for the purpose to run SHA-256 that much faster than the average validator on the network, maybe within like a 30% range. And so that means there's a reasonably tight bound on its runtime, which allows other validators on the network to basically assume that if a number of counts n has passed, then the amount of time that has passed, which would be n times this like minimum runtime of SHA-256, which in turn allows us to measure time in this slightly rough way. And just kind of revisiting an earlier point from our VDF definition, the other thing that makes this really neat is that even though this proof of history has to be generated in sequence, one by one, it can be verified in parallel. So another validator can look at a proof of history, which is on the ledger, and then really quickly verify that all of these outputs of the hash function are legit. Basically by dividing up into slices and having one core validate each slice. Which means that, for example, on a 4,000 core GPU, it takes just 0.25 milliseconds to verify 1 second's worth of these counts and hashes, which is pretty amazing. So far, what we've established is that proof of history can be used as essentially a clock to measure time between different events associated with hashes and counts in this proof of history record. But another question that we have to answer is how proof of history is actually used in the real world context of Solana to improve performance. And to answer that, on Solana, when a validator proposes or votes on a block, basically some event happens. It's recorded directly into the ledger. And that allows all these other validators to actually check that enough time has passed between blocks directly from the ledger. So in a lot of other blockchains, they actually have to like talk to each other to make that decision again. And then here, because the full state of the Solana network is recorded directly into the ledger, like who's voted, what blocks have been proposed, and which time, they can simply infer the state of the network from the ledger and vote without having to fall into any of the delays that peer-to-peer communication introduces. And the key result of this is that the Solana network is never delayed. There are a couple other features of Solana, which, for example, like how the block producers are selected and rotated that make this possible. But the key takeaway is that Solana is able to continue publishing blocks every 400 milliseconds, which if you remember that Ethereum was like around 8 seconds and Bitcoin is around 10 minutes is like pretty insane. And on top of that, Solana also has 7 other key technologies, which work together with proof of history to optimize other things like transaction processing. If you remember, that was the other bottleneck that I mentioned earlier. storage on the ledger, and more, which altogether allow for a blockchain that can support over 50,000 transactions per second and over 200 nodes or distinct actors. So this is what helps it ensure that it's decentralized. Whew, so that was a lot, and that was pretty technical. But our main takeaways, again, are that these technological innovations enable Solana to be really, really fast and really, really scalable and performant. But since we actually are concerned, of course, with building applications that are hopefully useful to people, the question is, what do we do with the fact that Solana is so fast and so scalable? And so this is where we'll talk a little bit about that. So a little history to get us started. The Solana is actually pretty young. Like, Anatoly came out with this white paper back in 2017, not too long ago, almost, I guess, like 3 years ago to the date, where he was like, how might we have a way to actually have a trusted like source of time in blockchain? And how might we actually have this decentralized network of nodes have the performance of a single node? So he publishes this white paper and implements a prototype in C. And then in 2018, his old buddy from Qualcomm, Greg, takes a look and he's like, this is really cool, but you should really move this project to Rust. It's just like way more secure. It's going to be more performant. Let me show you. And so he goes and moves the project to Rust and re-implements it, and also publishes the first open source implementation of proof of history. That is a pretty exciting and clearly has a lot of potential. So they move forward, and in July of 2018, just a few months later, they release a 50-node permissioned public testnet, which supports up to 250,000 transactions per second in bursts. And then fast forward to today, we actually have a mainnet beta that's been running for a couple of months since March. So Solana's, again, only been live on mainnet for a couple of months, but core infrastructure has actually still been cropping up pretty quickly. We're already seeing like decentralized exchanges, wallets, including like Math Wallet, which supports mobile as well, and even a cross-chain bridge, which, if that term isn't familiar, basically means an easy way to bring your assets over from other blockchains. So, for example, you can do this process called wrapping to bring your Ethereum over into like a Solana version, for example. And what's really neat about all of this is that it's all super composable. So you can write these Solana smart contracts in C, C++, Rust, and Move. Unlike other blockchains, they've left it pretty open for your sort of choice of programming language. On the other hand, though, I would say that like programming on Solana is definitely less beginner friendly, which is an intentional decision than, say, Solidity, Ethereum's programming language, because it's all optimized to be as performant as possible. So it is relatively low level, and there are gotchas that you have to be aware of, and also new foundational concepts such as like how accounts and storage work on Solana, that I would say take a little bit of time to kind of get up to speed on before you can start building applications quickly. That said, there is an open source Solana program library, which is maintained by the Solana Foundation, which includes production ready programs that you can compose and build on that allow you to mint and swap tokens. And they also have a CLI and JavaScript bindings available for those. So like when I first started playing with Solana, it was actually super quick and easy for me to just jump on and mint a Grace token. And now I'm the only owner of this totally valueless Grace token. But it's pretty cool that it only took like 15 minutes. But even beyond DeFi, what I think is even more exciting on a personal level is the applications that most people haven't really thought of or associated with crypto yet. To be honest, I think most people would probably categorize crypto today as really more of like a almost gambling space, this sort of like high profile, exciting like casino where people are like losing money and winning money in like huge amounts. You can see all the hype about Bitcoin going to the moon lately. But Solana's actual like scalability allows for a lot of these applications that people have talked about for a long time as sort of the promise of crypto being a relevant and useful technology for the masses. And so some of that could include decentralized identity verification. So blockchain, for example, could be used for me to like prove that I am me. And for example, another list or another application that I've shown here is, for example, it could be used for voting. And we've already started to see some early forays into using blockchain for voting. I think it was like 2018 that Sierra Leone actually used blockchain to record votes that were originally cast in person, so that anyone interested could actually go and like review and validate those counts. Beyond that, I think another super interesting application that we've started to see some interest in lately is around digital art and music ownership. So this concept of like non-fungible tokens or NFTs, which could actually serve as like a record of ownership. So let's say I own some piece of art, and actually it could even be a physical piece of art, but there could be this digital token that represents my ownership. And so when I, for example, go to sell this piece of art, I can actually prove that I own it dually through this physical object, but also through the fact that I own the only version of this particular token, which represents this painting. Beyond that, it can also be used for scaling things like 5G networks or for maintaining medical records. I think we all know how painful it is that that all hospitals seem to have their own system and they're very paper-based. And so taking advantage of both the relative anonymity of blockchain and the fact that it's public at the same time means that we could have this verifiable public record that is still pretty difficult to trace people's private data back from. And of course, a personal favorite of mine is also for gaming. And I think we've all seen how virtual currencies can be really valuable in gaming, but this is a particular way where it can be tied a little bit more to, like, I guess, the real world currencies that we have without having to go into all of the drama that we see now about handling payments through these third-party processors that might take fees, for example, not naming names. But that's pretty much just like a selection of the things to start you off, things that you might imagine building with a super performant scalable blockchain, but definitely welcome any more ideas above and beyond those, and hope you learned something today. If you have any questions, feel free to reach out to me directly at GCQuan on Twitter. I'll be super excited to chat with any of you who are interested in learning more about this topic, because to be honest, it's only one that I've gone into over the last year, but I think it's endlessly fascinating. And so I hope some of you have been inspired to learn a bit more about it too. Thanks so much.